In the previous topic, you have learned how embedded systems differ from general computing systems. We know that embedded systems are designed using special purpose hardware and embedded OS to perform a specific set of tasks. It's very interesting to know about the specific tasks done through the embedded systems by exploring its historical events. Here we go. Have you ever wondered how the remarkable development of the embedded industry has made our life so simpler and easier? It is all due to the invention and development of semiconductor technology. Because without semiconductors, there is no microcontroller or microprocessor, and without them, there will be no embedded systems. Hence, it is important to know the efforts of various reputed industries which have made the embedded market more successful. So, let us take a look back at the major events that have marked the history of embedded systems. In 1944, the world's first programmable electronic digital computer was developed for the battle purpose. It was named as the Colossus Mark I and Mark II computers. The computer was specially designed and used by the British code breakers to read the encrypted German messages during the Second World War. In 1960s, a most crucial NASA's lunar mission program called Apollo Guidance Computer was started. The project was developed by Charles Stark Draper at the MIT Instrumentation Laboratory. This is the Apollo's guidance computer, and it was the first computer to use integrated circuits with 1 MHz clock, 4 kilobytes words of read-only memory, and 256 words of random access memory. This is the user interface, which has a 7-segment display unit with a keyboard. It acts as a communication bridge between the astronaut and the computer. It provided the astronauts to input their commands numerically. MIT professor David Mindel, who is the author of Digital Apollo, says the Apollo guidance computers were early examples of what we would today call embedded computers, which now appears in everything from iPhones to automobiles. Thus, Apollo guidance computer became the first recognized modern embedded system to this world. Later, in 1961, another one crucial military project was initiated. It was the Minuteman Missile-1. For this, the Autonetics D-17 guidance computer was developed. It was built from the discrete transistor logic and had a hard disk as its main memory. It was also the first embedded system to be produced in large quantities. In 1965, the first computer embedded in a commercial instrument was launched. It was a 12-bit PDP-8 mini-computer. Consequently, in 1966, the Minuteman Missile-2 went on production. This came up with several major technical advancements in the Autonetics. It replaces the old Autonetics guidance computer with the new microelectronic guidance computer, which was lighter in weight compared to its older version. The second version was developed with a high volume of integrated circuits. This process reduced the cost of integrated circuits from $1,000 each to $3 each. Due to its affordability, integrated circuits came into use on various commercial products widely. In 1968, Intel was founded by Robert Noyce and Gordon Moore. The beginning of Intel led to the evolution of microcontrollers and microprocessors, which is the heart of many modern electronics. In 1969, microprocessor-based fuel injection system was introduced in the Volkswagen cars and was a breakthrough in the field of the embedded systems. In 1971, Intel 4004, the first 4-bit microprocessor was developed by Intel scientists. In the same year, TMS 1000, one of the most successful 4-bit microcontroller, was developed by another semiconductor giant, the Texas Instruments. Further, in 1974, the Intel 8080 was developed, and it was the first microprocessor to be used in a personal computer. And in 1980s, microcontroller became the demanded technology. The microprocessors are optimized for speed and memory size, whereas the microcontrollers are optimized for minimized power consumption and physical size. In 1983, HP 150 personal computer was introduced by Dave Packard and Bill Hewlett. It was claimed to be the first computer to be featured with touchscreen sensitivity. In 1987, VxWorks, a real-time embedded operating system, was introduced by Wind River Systems. And this real-time operating system was used for NASA's Mars Pathfinder mission in a later year. In 1989, one of the embedded systems, dot matrix printer, was restricted to 8-bit due to power expenses and tight timing and electrical constraints. In 1992, the embedded systems went wireless and nearly 10 million mobile phones were manufactured using embedded systems for controlling their functioning. In 1996, the renowned software giant Microsoft entered into the embedded market and designed its handheld personal computer using Windows CE 1.0 operating system. Following with Windows OS, in 1999, the Linux Foundation started to develop its roots in the embedded system. And at the beginning of the year 2000, a second parallel revolution occurred in the embedded systems. One of the highlights was the launch of the real-time version of Linux by TimeSys Corporation. In 2005, the multi-dollar companies Intel, IBM, and AMD released their first multi-core processors. And by the year 2007, the reputed American multinational technology company Apple released its first iPhone mobile. Following the Apple iPhone in 2008, the first Android phone was launched and the Android code became an open source OS. Finally, when it comes to our contemporary scenario, over 95% of electronic chips producing in a year are for embedded systems. These are hidden in familiar objects which you see around and use every day. Another one technological breakthrough in current embedded market is the Wi-Fi connected smart appliances. The range includes microwave oven, refrigerator, coffee brewer, washing machine, etc. And all these appliances can be monitored and controlled via your smartphone app. But what will be the picture of embedded systems in the future? Predictions say autonomous network will become the talk of the town in the future. One of the most awaited projects in this arena is the self-driving cars. It's a fully automated driverless car. Market players believing this technology is going to hit the streets soon by 2020 and it's going to change everything. Let's hope for the best. Summary. From this lesson, we have learned the history of embedded systems, the position of embedded systems in the contemporary scenario,